So we can do the second derivative. We can do it as a product of two things. So the second derivative is going to be the derivative of the first, which is c e to the cx times 1 plus xc plus e to the cx times. What's the derivative of that?
C plus
C. It's just C. It's just C. Could you clean that up a little bit? Yeah. Y double prime is going to be equal to e to the cx times c times 1 plus xc plus c. It doesn't really matter, but you can if you want to. So, what rule do you want to use?
product rule.
Make it go to the top. He wants to do this. Y equals 4x times x plus 1 to the
Negative
1 half. Right. So y prime is going to be equal to the derivative of the first times the second plus the first times the derivative of the second, which is negative 1 half, x plus 1 to the negative 3 halves. Sure. Can you also use the quotient rule and then simplify down to the same thing? Sure. Is that technically the derivative? Yeah. If this was a test, I would really like you to go one step further in the simplification. You could say that this is 4 times x plus 1 to the negative 1 half minus 2x times x plus 1 to the negative 3 over 2. I would like you to go that far. So, what do you end up with? H prime of t is going to be equal to 3 times the derivative of tangent. What is derivative of tangent?
Secant squared.
Secant squared 3t. I like that. So what's h double prime going to be? What's the derivative of c? Well, this you have to be very careful with, because what does this mean? Let's clean it up a little bit. That means, we're not doing the derivative yet, that means 3 times secant 3t to the second power. That's what that means, right? So when you do the derivative here, what do you end up with? 6 times secant 3t raised to the what power? First, but then we have to multiply by the inside. What's the derivative of secant? What? Secant x. Well, not secant x, it's secant 3t tangent 3t times 3, because you have to multiply by the derivative of 3t. You have to do the chain rule twice. So the full, nice, simplified answer is going to be 18 secant 3t, secant 3t, tangent 3t. And what's one more thing we could do if we wanted to simplify that a little further? How many secants do you see? So that's the same as 18 secant squared 3t times tangent 3t. If your handwriting is not perfect, I highly recommend doing parentheses like that. How does that look, everybody? Right? Could you use the quotient rule?
Yeah.
Yes, or could you easily use the product rule?
Yeah.
Well, that's equal to 2x times 1 plus x to the fourth to the what power? So what is h double prime going to be if we use the product rule? The derivative of the first times the second plus the first times the derivative of the second, which is 1 plus x to the fourth to the what power? Negative second. But then we have to multiply by the derivative of the inside, which is 4x cubed. Now, can you simplify this a little bit? Yeah, you could write it as 2 over 1 plus x to the fourth plus, minus, right? Minus 8x to the fourth over 1 plus x to the fourth squared. That looks a little cleaner than what I just wrote. That would be great. That would be a very good form of the answer. And what do we end up with? Minus what, 15 over 3x plus 2. Is that correct?
Yes.
Let's go back here for a second. What does y equal? What does y equal?
This whole self.
We have to put it in.
We know this is true, right? Do you agree?
Yes.
So ready? Y prime is equal to x to the 3/4 times the square root of x squared plus 1 all over 3x plus 2 to the 5th times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. Done. Why is that a heck of a lot easier and cleaner than what you just did? That seems like it's longer than what you just did, but can someone tell me why that's nicer? Why is it nicer? A product, so that's going to turn into ln y equals ln of 2x plus 1 to the 5th plus ln of x to the fourth minus 3 to the sixth. Now we drop them to the front, the exponents, and we end up with ln of 5 ln 2x plus 1 plus 6. Yep, like that. Very good. And now what do we do? Now take the derivative. So 1 over y prime is equal to 5 times 1 over 2x plus 1 times plus 6 times 1 over x to the fourth minus 3 times 4x cubed. So you get y prime is equal to y times 10 over 2x plus 1 plus 24x cubed over fourth minus 3. So you now know that y prime is equal to, you got to do the substitution at the end, 2x plus 1 to the fifth times x to the fourth minus 3 to the sixth times 10 over 2x plus 1 plus 24x cubed over x to the fourth minus 3. All done. There's your final answer. So it's going to be ln of x to the y, not 4, y, equals ln of y to the x. What can we bring to the front? Wow, y ln x equals x ln y. Now we differentiate. What are we going to have to use on both sides? The product rule. The product of two things on each side. The derivative of y is, so that's y prime ln x plus y. What's the derivative of ln x? 1 over x equals the derivative of the first times the second plus the first times the, what's the derivative of ln y? 1 over y prime. Now I'm going to highlight what we're isolating. We're isolating the y primes, correct? So where do we need to put them? On one side. Very good, Julie. So this minus x 1 over y prime. Yeah, I make kids earn it. I get them to be happy when I call them by their real name. This. You see that? You got it? All I did, that was just algebra right there, everybody. I took this and I put it on the other side. That's all I did. And then I took this and I put it on the other side. What can I factor out on the left now? ln x minus x over y equals the same thing here. Now what do I divide by? Minus x over y. So y prime is going to be equal to ln y minus y over x all over ln x minus x over y. You're done. You're done. Know the trig derivatives perfectly? So we know now that y prime is equal to y times 2 times 1 over sine x cosine x plus 2 times, what's the derivative of tangent? What's the derivative of tangent? Squared x minus 2 times 1 over x squared plus 1 times 2x. Exactly. You got it. Like that. So now we know that y prime is equal to, what was it? It was sine squared x tan squared x over x squared plus 1 squared times 2 cotangent x plus 2 secant squared x over tangent x minus 4x over. All done. Does it look pretty nasty? Sure.